searched the world over and thought I found true love. You met an AI and poof, you was gone.
Hi, this is Jeff Pennington, host of You Teach the Machines. No Mary Jane today. Instead, please join me for an interview with Stephan von Muehlen, CEO of Poursteady, a division of Steady Equipment Corporation, a manufacturer, designer, builder in Gowanus, Brooklyn, New York. Stephan and I discuss onshoring of manufacturing, domestic manufacturing, supply chain issues, and important to this AI podcast, the potential for AI to actually aid in just-in-time manufacturing using automated methods like CNC and 3D printing. Hope you enjoy. Please check out Poursteady at poursteady.com. You can also check out the AI vendor that we discuss, Intercom, and their product Fin AI.
Don't worry about it.
Earlier, you said something to me which made a huge impression, that there's a generation of machinists who are 60s, 70s now?
Yeah.
Right? Who picked up CNC, who picked up maybe 3D printing, sort of in the first wave of adoption of these things?
Maybe not, but yeah.
Post-manual machining, right?
Yeah, and manual machining in general.
And manual.
Yeah.
Okay. And then there are kids who want some connection between the digital world that they grew up with and the physical world?
Yeah, I mean, you look at like the maker, community or culture.
Yeah.
Like it's been kickstarted, I guess pun intended, no pun intended, by everybody sort of trying to do it themselves. DIY, like do it at home.
Right.
And the most exciting products in that space have all been like the MakerBots, the 3D printers, the laser, whatever it is, like laser cutter, water cutters. That stuff for 15 years has been what's sort of been because electronics and making shit overlap, with people who want to make stuff. It's both now.
Right. So it is both. So there's the Raspberry Pi generation, who
Arduino before that,
Arduino generation, who are also the first home 3D printing generation.
Yeah, and they were all people that didn't really necessarily, maybe they got some of the last like shop classes in their schools if they went to a high school that had one or something. Like all of that education has been gone since Gen X on, right?
Right. Well, that's the other, as part of that conversation you said, there's a generation of machinists who maybe were adopters or are adopters of CNC computer-controlled machining. They still do manual machining too, whatever it takes.
Yeah, no, I mean the industry adopted CNC machining in the 80s and 90s. Like it was hard to used cassette tapes, and it was retrofitted onto old machines.
Right.
And there are technicians and machinists who like set them up and haven't had to reprogram them since, probably for some jobs.
Yeah. Because they know how to use them.
So there is.
But then there are these kids who grew up with Arduino, Raspberry Pi, and early 3D printers, but no shop class.
Right, but no shop class, But they might have had a dad, an uncle, They might have figured it out, and that's how I was not brought up to be a machinist,
Yeah.
Like I went to Catholic school and college and stuff, and it was like after college that I was working in art galleries and ended up working in a metal shop where like all this stuff was, and I had a friend who was more of a artist sort of fabricator at the time who started to collect old machines, and so I like got to touch a lathe.
But your point about the kids, quote unquote, because we're both in our 50s, right? God, I hope you're in your 50s.
Yeah.
Yeah, I'm rooting against you.
I think I'm older than you.
But the quote unquote kids want a connection to the physical world. They're not satisfied with just like purely digital and virtual. And you also said that like the guy that runs one of the machine shops you work with, he's having a succession problem because he had a successful business. He sent his kids to college, and now they're bankers, right?
Yeah.
They're purely offline, purely digital, not in the physical.
And it was on his watch that he ended up, with 50 CNC machines, like multiple lines of Swiss turning machines and 5-axis and 3-axis machines, and like when we started working with it, they had 2 shifts a day. They were doing 16 hours on 50 CNC machines with finishing and all the tracking and labeling and stuff for government work. And they hadn't updated their website in 30 years at that point, 40 years now.
Yeah.
But yeah, it's like
now are they like working on whatever they installed 20, 30 years ago? like you said, the sort of first generation of CNC adoption?
Well, I mean, that whole industry sort of matured, like that basic machinist stuff,
Yeah.
became computer controlled in industry, and shop classes went away. So now there's kind of blue collar workers that know how these CNC machines work, and there might be and then there's a lot of engineers who learned it in college, because they've all had shop classes there. That's where you play catch up if you're an engineer.
Yeah.
But, if you're not an actual engineer, if you're a bullshit engineer like me, the normal path would be to start to figure it out yourself. Right. DIY it.
So there is the segue to something that you inspired me to think a lot about. A conversation, I don't know, it's probably 6 months ago now, could have been 4 before today. Let's go with that. Where you said you and somebody else here, I can't remember, you'll remember who it was probably. You sat down, you had an LLM on the left, CAD in the middle, and the McMaster car catalog on the right, and you were doing math to figure out how to adjust, optimize the build for the Poursteady coffee machine to get better flow out of the nozzle.
Yeah, and that was my first technical conversation with ChatGPT.
Right.
Because it was questions that I'd had for engineers for years that I hadn't been able to find the person to ask or have the relationship with that person to get to that or whatever. So it was sort of it's hard to do with this physics and trying to find that there must be a way to do it and can determine the length of the tubing based on the temperature and the...
So I haven't heard the resolution to that. You said, I'm sitting here doing this. We haven't talked about that since then.
And right now what it is, it's a prototype. It's the same prototype I showed you.
Really?
Actually, and an arbor press. So a cast iron arbor press that isn't worth shit and some 3D printed molds. And I proved to myself, and I did see an improvement. It still needs tweaking and all of that stuff, and it needs to be, and it's not as long as what ChatGPT recommended, so I could make the next prototype and order more materials, but I moved on to other stuff, but it's in the bag as something that in a future, when we have the resources and the priority set to be working on, new product development, that will be one of the features that we could pursue.
Sure.
Because we know,
So you got from, I have questions I've always wanted to ask about laminar flow to a prototype?
I actually started with, I think the first prompt was how, and I knew that was the thing, you have to ask the right questions, and I asked, I was how many, because I knew that from YouTube that if you stack a bunch of straws together and pour chaotic water through the top, it comes out as laminar flow at the bottom. It's a hack. Yeah. So all the DIY YouTube nerds that I actually watch it's bad TV.
It's good TV.
Reminded, I was oh, that's laminar flow, and then I was, and I know how our machine misbehaves.
Yep.
And I know we've been trying to figure out how to make it Poursteady because that's the name of our company.
Yes.
So whatever, this is a little simple machine that runs in my mind for a decade.
Yeah.
And so I knew enough to ask, what diameter and number of tubes that would fit inside, tubing to make laminar flow happen at this temperature and flow rate. Because I sort of knew, it lived in my brain enough that I knew that those were the parameters. Yeah. So I was able to say what the fuck does that, and it was able to sit there and do the research, show the math. Yeah. And, say, or whatever the fuck it was.
Yeah. Okay.
And then I was able to open up, use the ChatGPT also to search the internet to find tubing. Yep. I think it suggested tubing when I asked, what's the thinnest small wall, tubing I can get? And I don't know if that was ChatGPT or my brain. I would have to go back and look. But I found, through regular internet searching, I might have used Google to do it. I might have used ChatGPT, but I found the company that in America that sells tubing. Then I could tell ChatGPT, we get closely packed circles, with using, the dimensions for the diameter.
Yeah, okay.
Then we get down to you can do 6 or 9 or whatever it is that the circles that pack inside of a circle. So then suddenly it became nerdy turn of the 19th century, geometry, pattern recognition, stuff, which, show me a grid with information, my German roots come back up. So
you got me thinking about the Brooklyn Bridge.
Yeah, cables. No, exactly. Yeah. So it looks like the cross section. It's exactly it. It looks like the cross section of cable.
Right.
And you can't do certain numbers because you don't go around the outside in a symmetric way.
Yep.
You know, so you need either a center of 1 or a center of 3 to build around. Or,
They laid them up that way.
Yeah.
They laid them up starting at the bottom, and they stacked. They stacked horizontal layers to get to the round result. Yeah. So
anyway, so I was able to have this. You know, we are like the ADHD with ChatGPT, and we're like off to the races.
Right. So that got you to a prototype. The rest. Like,
I got it to a TRL of 3. Right.
What's a TRL?
Oh, technology readiness level
Of 3.
Do you know the TRL?
No.
It's like if a 0 is like the idea, a 1 is like a drawing, and 10 is like deployed in space.
Okay. Never. Or you got to send the space shuttle and a guy in the air.
But it also could be like the customer. I mean, if you take the aerospace metrics or whatever and apply it to, like, it could also be like the customer has the tool in their hands.
Right.
You know what I mean? Like it's fully.
So the tie back or the closing of the circle with this conversation is that access to expertise got you a whole lot further than you would have unless you knew a laminar flow engineer.
Yeah, and I'd hired somebody with fluid dynamics specialty in their history, and he spent the better part of a year getting closer, but not really solving that problem.
Working on other problems too?
I mean, yeah, but also like, you know, there are all kinds of engineers in the world, and they all have their place. And this guy, you know, documented everything really well, but wasn't really solving the problems we were trying to solve, and wasn't able to. And he also wasn't managed properly. You know, lots of reasons. But
I'll edit this too, so it's.
But you know, there are engineers who can kind of pick their head up out of the hole and see what they're doing, and then there's other engineers that can just keep digging. And like, if you keep digging, you know, you might get deep, but it might be the wrong hole.
Right.
And you know, and it's a pretty big split between those personality types or those people.
Yeah. So bringing this back around, in some ways you were the kid who didn't have shop class, right? You are interested and have built a career, a life on the convergence.
But I was the technical director of the high school music. And in college, I made some pretty trippy environments for a music festival. So I knew how to like make stuff, but nobody had told me how exactly.
You built a life making stuff.
Yeah, and that
you built a business that makes stuff.
Well, I wanted to make things. It's like I wanted to be a painter at first, and then you know, and
you've created something that is incredibly beautiful to me, which is a domestic electronic equipment manufacturing company, right? Design build company, successful with positive profit margins.
Yeah, I mean, some years, yes. Yeah.
But closing the loop on manufacturing, you are also looking at this. There's the sort of first generation of automated, semi-automated, computer-controlled machining. There's a generation of kids who are who are in the workforce, entering the workforce, and then but they didn't have shop class, and
they grew up in a service economy.
They grew up in a service economy where they ordered stuff, they didn't make stuff.
Yeah, like everything is a service.
But they want to make stuff.
Yeah, no, human beings want to make stuff.
Amen.
Yeah.
So you're looking hard around the Poursteady operation at what you can manufacture in terms of parts, basically how much vertical integration you can pull off with. So it's instead of design, specify, send out to a contract manufacturer, it's design, specify, make the part in-house, assemble into the finished product in-house.
And yeah, I mean, that's a moment in time right now.
Right.
Yes. It's like it's been, the world changes and I change and my role changes and everything in between. But you know, what Poursteady did intentionally from the beginning, like on purpose, was make stuff in America or make stuff with really short supply chains and not compromise on quality. So we have Swiss-made motor controllers and Japanese motors and Italian, you know, valves from commercial coffee equipment stuff. We weren't trying to like, you know, reinvent the wheel. We just were going to make something without compromise. And get the parts from work out. And we could tap into the machine shops and sheet metal shops and stuff that we'd worked with for other projects in New York for years.
Right.
Or not New York, Pittsburgh, wherever the founders had done stuff. You know?
Yeah.
So, and my partner also at the time really was an engineer's engineer. He wanted to keep things efficient, and like, you know, if he'd had his way, we wouldn't have sold anything internationally, and it would have been like a couple year project of making some nice stuff and then moving on. Instead, we ended up kind of catching waves in different parts of the world, and it went for 10 years.
Right.
But we intentionally made it so that like all of our suppliers were as close as possible as we could, and the exceptions we made for proximity was long-term relationships. So we had some shops in California that we never replaced because they were good at it, and or one of my founders and co-founders had worked with them before. Yeah. And then just industry standards. So we were getting motion control from Switzerland and Japan, and you know, espresso commercial coffee equipment parts from Italy. Like, it all made sense. Yeah. But what's happened in the meantime is that we can't even get the metal cut and finished here anymore.
It's getting harder and harder.
It's getting harder and harder. Like, vendors that we've had are not, you know, aren't making as good parts with the same time, and it costs more. Yeah. And that was happening all by itself, and then the tariffs happened, and this stupidity, like, you know, inflation was experienced for multiple reasons all at the same time.
Yeah, their inputs got more expensive because of tariffs.
Yeah, and as a result, our margins went down and our sales were threatened in our markets overseas. You know, like double whammy.
From both ends, yeah.
From both ends. And so all alternatives are, as far as I can tell, to like, and our mantra for next year is to bring costs down across everything because we need to be profitable, right? Yeah. Our options for bringing prices down means we still need to find quality, well-finished, accurate parts for our metal. And while it served us really well to do that stuff domestically for our careers until now, that system just broke, and the online portos to Chinese factories are mature. Yeah. And the way I frame it, like, either we make it ourselves, like in-house, or we let the market compete and we take the best deal. Yeah. Where before we were like a lifestyle business and we didn't want to have to deal with international suppliers in Asia. Like, I'd done that once at another job, and you know, it just seemed like not a good idea for us. And then it really paid off during the pandemic when that supply chain crisis happened. Yeah. Before all the tariffs, you know, we were able to catch a wave in the Middle East and make a bunch of machines because we had kept all of our supply chains so short and with relationships and not dependent on, you know, industry scale beyond ours. We were insulated from a lot of that stuff.
So making in-house or letting the market compete, and
we have to compete with the market. So suddenly, like, as a 3D printer in-house better than a CNC machined aluminum part in you know, Thailand or China or Mexico or wherever. Right. You know, and if the 3D printed part can perform mechanically in the same way as this machine part, we don't need to get a $20,000 used CNC machine and keep it running, or we don't have to get a $100,000 new one and hire a $100,000 machinist to run it. Right. We can print these parts with like a little extruder, and it works just as well. And then we'll do that. You know, like suddenly we're like freed up from, you know, the old laws of physics, and we have a new, you know, looser laws of physics with other compromises or trades. But if it's spec'd in engineering and engineered to spec, then manufactured to spec, then we can do the same. Right.
With the design build sped up and made more accessible for you here, like, or when you
I mean, we've made a really complicated product. Like, so design build is kind of like, you know, we assemble everything. Yeah. And we manufacture.
I'm sorry, like design manufacture part, not design build machine. Right. Design and manufacture part. You design the part. Like
we specify the parts, right? So we use off-the-shelf parts where we can, and then we make, you know, the custom bits.
You showed me a model for a part that when printed out of plastic and
filament and carbon
fiber will replace 4 pieces of
5.
5.
One part can replace 5.
And those are all CNC machined aluminum. bits?
Yeah, they're simple parts that are machined. So like whether they're machined by hand or CNC, I'm sure they're CNC because they were sort of repeatable.
Yeah.
But there's nothing about the geometry that makes them like.
It could have been an extrusion.
I mean, it could have been an extrusion. The holes could have been drilled on a manual machine,
Sure.
or you could have had jigs made and then do it, in an old school way. And we could still do that. Like I could make a drill jig with drill bushings that lay out all the holes and all of them.
How hard is it for you to not do that? That's me knowing you well.
Yeah.
Knowing that you're like, fuck it, I'll just make it with a drill press.
Yeah, no, I mean, and there's a drill press. There's 3 drill presses within 100 feet of me that I can go jump on right now. And there's also an old Bridgeport, and
Yeah, but how old's Shep?
He's 10, 9, almost.
Connie?
10, 7, almost 8.
Yeah, well, 10 years ago you had the time to use the drill press. Now you don't because you have 2 kids.
Yeah, yeah.
So I'll edit their names out. The point here is, and you showed me the model or the design of that one plastic part that replaces 5 metal parts. That modeling in CAD is something that you bootstrapped yourself, taught yourself to be able to do.
I mean, I was exposed to it in graduate school, and then my first job required that I do it, and I had shop experience where I'd use the output of those things before grad school. So by the time I sat down with SolidWorks and was paid to do it, I'd been receiving it for forever and was going to be operating the machines that I was designing the parts for. Okay. So yeah. And I was a professional machinist by the time I became a professional machinist.
Got it. I'm running out of brain power this afternoon.
Yeah, we talked and we're so ADHD'd out that it's hard to keep the thread.
It is. But bottom line, this make it in-house or let the market compete.
Yeah. As opposed to keep your supply chains short.
Right.
Because we paid a penalty, literally in price. We've been leaving money on the table for years. Because the truth is like we were using domestic CNC machine shops and sheet metal shops that serve government and medical industry. And we're making a commercial piece of coffee equipment, an industrial piece of equipment. It's a business to business sale, and that was why we picked, that's why we entered the coffee market, is because you could make a $10,000 machine that you were competing with $10,000 machines over. It wasn't unheard of, so you could do this stuff without compromise at the scale that we could manufacture them because we had some of the means of manufacture and could integrate stuff. But now, the price we paid for those parts were what the market asked for, but like I said, we're not Lockheed Martin and we're not even the MTA. We're these pencil neck geeks trying to make coffee equipment with really high standards. And
when we've discussed this, it seemed like for you the quality slipping, the unpredictability of the quality, and also the time cost of the relationship.
The emotional labor of my employees into these Goombas. I'm sorry, I love all my vendors, but it's a lot of work to make my peer group, my colleagues, culture work with the aging out, military machine shops of the tri-state area. Yeah, and it's a lot of work. It's easier to find an interface online or communicate.
And that was you didn't when we've had this conversation. At no point did you say up front they got too expensive. What you started with was it just got harder to get good stuff. Yeah. Right? Yeah. It just got harder to get.
No, and their prices went up, and their margins
and their prices went up.
Yeah, I mean, but that's inflation. I get that. That's inflation. They're experiencing. They're paying.
If you had to pay them 20% more, and you were still getting.
I mean, we were paying them 20% more from where we started. But where we started was by the time the tariffs hit, and we started to decide to look at where we could trim and open up the doors to the whole world to see what we could expect to pay for stuff. Mm-hmm. Our costs definitely went up 20-30% since we started. Mm-hmm. But we started at 3 to 5 times the price of what we could be getting in.
Well, you could have back then.
What we could have been getting in Asia then.
Right.
And so even now with the tariffs and them doubling the price and all that kind of stuff, it still should come in at roughly half. The volumes we're doing of what we're paying now
to go overseas,
to do it overseas.
Yeah.
So and we have golden articles. We have perfect samples because we've been selling products that the guys that made those samples can't seem to do reliably anymore. You know what I mean? Okay.
Why?
And the communication problem with Asian manufacturers used to be, and to some extent probably still is, you gotta fly there, you gotta show that you care. But if you have the right relationship or the right network and you're using the right software to communicate between parties and you have a sample you can share, then suddenly, we're all looking at the same things.
Right.
And there's enough trust built in the network that
this is not me
get your part.
arguing for or against letting the market compete. Are there domestic suppliers, domestic machinists, domestic suppliers that could, instead of like it's half as much by going overseas, it's 3/4 from where you are now, and you've got to. It's not, the supply chain isn't 4 blocks that way. It's 4 states that way.
I mean, it doesn't matter. That doesn't matter now. It's the hard part in getting things made is communicating your intent to the person who's making the part, or swinging the hammer, or applying the brush to the wall. Whatever it is that you're doing,
that's the hard
if you're an artist or an engineer, you have a vision that requires specialization, and you find those specialists to do that part of the labor. And that communication is breaking down now because the conversation is sort of one-sided. The other side of the conversation is aging out or whatever. Or I'm not having the right conversations with the right people, but our supply chain is getting old and starting to show its age. Full stop. And there is not a generation of businesses in the tri-state area to fill those shoes. Like in the Bay Area and in Boston, there's more. And you have design firms and engineering firms and medical device companies and robotics companies, and those things kind of exist. I think they're bucking the same change over time at a different phase. Maybe now things will change. I don't know. But New York is like old school, as far as manufacturing goes. We're a finance company, or state, or entertainment, or agriculture, or whatever, but we're not a manufacturing powerhouse.
Right.
So the communication with the Goombas that are still around gets harder and harder as they get older and my employees get younger. There's just a divide, a cultural, generational, technological communication divide.
Also a divide in sense of urgency, right?
Right. Yeah. No, those guys have been. I mean,
they
did a great job. They made it to retirement. Their succession planning isn't great, but they're living a version of the American dream. Like our sheet metal guy just moved to Portugal or something, and whatever. The other guy sent his kids to Goldman Sachs, or to high expensive schools in Goldman Sachs, and he's piecing out. But I think he's frustrated because he would like to be machining, but he's just
he's tired.
He's 90.
Yeah. He's 90. He's 90. I'm gonna try and tie a bow on it, which is always interesting. The in-house manufacturing with automated machinery, because now it's capital, not labor, to produce the part.
Right, but also the capital has come down by an order of magnitude for some things.
The printer, right?
Yeah,
but not necessarily the CNC machine.
Not necessarily the CNC machine, but whatever. I have a very smart employee who's a recent engineering student who graduated, last year, and he had some shop experience for sure.
Okay.
But in 2 days, he was able to get the CNC router next door up and running, and create a little user guide for the other members of the studio, just by being smart and relatively unafraid and using ChatGPT for every step.
Right.
And so he was able to
cut
parts.
You're helping me put a bow on it, which is that the accessibility, the democratization, the sort of transfer of expertise through LLMs, right, has the potential to do what you just said, which is to take somebody, have somebody on your team teach people to fish pretty quickly on a relatively straightforward machining task.
Yeah.
Right.
I mean, I want everybody to be makers. I want the people assembling the machines and the designing the machines to want to make stuff like I do. And that's a bias ultimately, and to do that responsibly is the challenge.
Right.
And to be profitable as a small business trying to grow is another challenge, so it's a pretty constrained problem.
The best ones are.
Yeah. But a constraint problem is actually not bad.
Constraint problems are awesome.
Because then, especially with an LLM, you can talk about the constraints and get some expertise
and get
tailored for your needs.
And get to the point where you've got a laminar flow with a TCL. Technology readiness, TRL of 3.
Yeah, whatever.
Blah, blah, blah.
Not to be quoted, I'm sure. I'll look up what I'll tell you what the TRL is later. We'll find the chart that can give us the definition. But yes.
All right. Well, we've had I really appreciate this conversation. I'm always searching, looking, trying to find a path for the technological changes that we're undergoing right now to work out better for people than for faceless corporations.
Yeah.
And you and Poursteady, I've always find inspirational in that regard. And I spent the morning with Derek seeing how your small business is able to scale because of Derek's incredibly thoughtful, creative, and ultimately highly accountable use of Intercom and FinAI to help customers get a better resolution to the support problems that they have, right? Without breaking the bank here, right? You got talk about a constrained problem. There was no way your margins were going to support a call center. You just couldn't. Right. So what do you do? Right. And so in that regard, 3 years ago, you were between a rock and a hard place when it came to scaling the business, because there's an inherent you build products that aren't throwaway. They are
and we used that. We made lemonade out of that, because what we were able to do is let everybody from the company experience what our customers were experiencing. Mm-hmm. So kind of throughout the culture, everybody sort of knew what was important and what needed to get fixed and what was not important.
Right.
And it was because we were less than 10 people in a room in a way, and the support shit was so painful that you kind of had to play hot potato with it. And everybody that accepted that potato did an amazing job. So we had the data set because we were communicating on digital tools. And so when Derek,
emails, you had Google Sheets, you had
and Derek was the last one to hold that potato, and he needed to put it down. So he used all of the information we had.
He is such a joy to learn from with all of this, right? It's really remarkable. I think and now to some extent you have that as a success, ongoing, always learning, iterating, improving, optimizing, and you are trying to see how much of the rest of your company can thrive, grow, more specifically in how you make the stuff you make.
Yeah.
All right, we'll wrap up with that.
Yeah. Thank you, Jeff.
Thank you so much. Not long after we recorded that interview, Stephan voluntarily stepped down as CEO and promoted his CFO, or head of the business side of things, Travis, to CEO, which was a very mature step for a CEO of a company that is completely invested in what he's doing, so much so that he saw that he wasn't the best fit for the job. He's now director of product and engineering.
Ones and zeros, vectors and scalars. What do you see in that machine? I gave you my heart, my warmth, and Snapchat. You chose a robot, now I'm alone.
You Teach the Machines is hosted and produced by me, Jeff Pennington, and co-hosted by my daughter, MJ. Look for my upcoming book, also called You Teach the Machines, in the summer of 2025. Please take a minute to review and subscribe to You Teach the Machines wherever fine podcasts are downloaded. Copyright 2025. Any and all use of the audio recording of You Teach the Machines for training or other contribution to artificial intelligence models or their application is expressly forbidden without the permission of the creator. And we'd love to give you permission, so long as you come on the show.
Poof, you was gone.